explorers! Today we're embarking on a journey to unravel the physics behind the everyday experiences. Our destination will be at faculty office. Let's go! Hey, did you check your BMI?
Yes, I measured my height 6 feet and weight 132.28 pounds. Can you convert them to kilograms and centimeters?
No problem. Let's convert the height to centimeters and weight to kilograms. Let's go!
In this problem, we need to convert Ivan's height, which is 6 feet, to centimeter, and his weight, which is 132.28 pounds, to kilogram. So now we're gonna convert the 6 feet to inches. So 1 feet is equals to 12 inches. So we need to cancel the feet and move on to the conversion of inches. So 1 inch is equal to 2.54 centimeter. So we need to cancel the inch and we need to multiply the 6 times 12 times 2.54 centimeters, and that is equals to 182.88 centimeter. So this is the height of Ivan when converted to centimeter. And now we're gonna move on to the weight of Ivan. So it is the same process, but this time in this problem, we need to convert Ivan's height, which is 6 feet, to centimeter, and his weight 132.28 pounds to kilogram. So now we are going to convert 6 feet to inch. So 1 feet is equal to 12 inch. And we need to cancel the feet so we can multiply it later. To convert centimeter, we need to convert the inch into centimeter. So 1 inch is equal to 2.54 centimeter. Cancel the inch and multiply 6 times 12 times 2.54 over 1 is equal to 182.88 centimeter. And this is Ivan's height in centimeter. And now, here is Ivan's weight. We need to convert it to kilogram. So 2.2 pounds is equal to 1 kilogram. So cancel the pounds and multiply 132.28 pounds times 1 is equal to 132.28 divided by 2.2 is equal to 60.13 kilograms. And that is Ivan's weight in kilograms.
What's with your face?
I came across a complex calculation and my answer has so many zeros and I need to simplify it.
Let's simplify it down. We will convert this into an easier to understand from using scientific notation and engineering notation.
Oh, I see. Thank you, Jai.
Scientific notation is a way to express numbers usually in the form of a times 10 to the power of n, where a is a number between 1 and 10 and n is an integer. It's commonly used for writing very large or very small numbers. For example, our given here is 25 million. The first thing we need to do is to identify the coefficient a, or the non-zero digits in the number. In this case, it's 25. Next is to write them as a decimal between 1 and 10. So it becomes 2.5. Then we determine the exponent n by counting the number of places you moved the decimal point to get the original number to be between 1 and 10. For 25 million, we move 1, 2, 3, 4, 5, 6, 7 decimal point to places to the right, and since the original number is greater than or equal to 1, the exponent is positive. Then it is positive 7. Lastly, we write the final result in the scientific notation, which is a is equal to 2.5 times 10 to the power of positive 7. Engineering notation is a method of expressing numbers using a coefficient and a power of 10 but with a twist. In this notation, the coefficient is a number between 1 and 1000 and the exponent is always a multiple of 3. Its general form is 8 times 10 to the power of n. First, let's identify the coefficient. In this case, it's 8 to 5. So we write this into decimal and between 1 and 1,000. So it will become 82.5. Next is to determine its exponent n. We count here 1, 2, 3, 4, 5, and 6. So our result is 82.5 times 10 to the power of 6.
Hey, Jai, have you observed that the students are concerned about their physics test scores? And they want to know if their scores are accurate, precise, or both. Oh, let's help them examine their test scores to determine whether it's precise or accurate.
Accuracy and precision are two important concepts in the field of measurement and data analysis, often used to describe the quantity of data or the performance of measuring instruments. Accuracy refers to how close a measured value is to the true or target value, while precision measures the consistency and repeatability of measurements. For example, the given shows that Dalisay got 17/20, Joshua got 17/20, Kishan got 20/20, Kim got 18/20, and Dalida got 19/20. So their scores are both accurate and precise. Accurate because their scores are close to the target value, which is 20, and precise because their scores are close to each other.
Let's help Ivan to calculate this vector problem by calculating the resultant displacement and the angles.
Ivan went to his friend walking 15 meters to the north. After that, he headed to the guardhouse walking 10 meters to the east. Now, he is curious about the resultant displacement, the total distance covered during these two trips, and the angle's direction of Ivan's displacement.
Given the situation where vector A is equals to 15 meters to the north and vector B is equals to 10 meters to the east. So for the free body diagram F3D, we have the vector A to the north and vector B to the east. To find the resultant displacement, we will use the Pythagorean theorem with the formula resultant displacement is equals to square root of quantity of vector A squared plus quantity of vector B squared. Resultant displacement is equals to square root of 15 squared plus 10 squared. So the resultant displacement is equals to 18.03 meters. To find the angles theta and beta that the Dalisay's displacement makes the north and east directions, we will use the trigonometric relationships. First, calculate theta using the tangent formula. Tangent theta is equals to opposite over adjacent. Tangent theta is equals to the opposite 10 meters and over 15 meters. Tangent theta is equals to 0.67. So theta is equals to arctangent of 0.67, where the theta is equals to 33.82 degrees. To calculate the beta, with the formula of beta is equals to 90 degrees minus theta. 90 degrees minus 33.82 degrees. So the beta is equals to 56.18 degrees. So the answer is as follows. The resultant displacement is equals to 18 meters and with an angle of approximately 56.18 degrees. Remember that distance is a scalar quantity, measuring the total distance traveled regardless of direction, while displacement is a vector quantity, representing the straight line, length, from the starting point to the finishing point.
I've been curious about the magnitude of Joshua's average acceleration. What if I calculate it?
On the way home, Joshua was riding a motorcycle. He started from the rest and accelerated to a speed of 30 kilometers per hour in 5 seconds.
The given are as follows. Final velocity is equal to 30 kilometers per hour and the initial velocity is 0 ms because Joshua started at rest and the given time is 5 seconds. We cannot calculate the acceleration because the units are not consistent. So, we need to use conversion. First, we convert 30 kilometers to meters and we have 1 kilometers that is equals to 1,000 meters. Cancel the same unit and proceed in converting hour to seconds. The same process for 1 hour is equivalent to 60 minutes and 1 minute is equivalent to 60 seconds. Cancel the same unit and calculate the remaining numbers. 30 times 1,000 over 1 times 1 over 60 times 1 over 60 and we'll get 8.3. Then copy the remaining units which are meters and seconds. So the final answer is 8.3 meters per second. Now, we can calculate the acceleration using the formula acceleration final velocity minus initial velocity over time. Our final velocity is 8.3 meters per second minus 0 ms, which is the initial velocity, and divide by 5 seconds. So, therefore, the acceleration is 1.66 meters per second squared. Thank you for joining our physics exploration. Until our next journey, keep exploring the world of science.